Well, good afternoon. This is actually Saturday evening, and I've decided that I want to talk to you about how to draw circles in Google Earth with particular emphasis on railroad track. Circles for railroad tracks. And I'm stuck at this point in the middle of my operation when I just sort of decided to do this. We're trying to locate a center line for a circle which goes to 3 past the decimal. Sometimes that happens if you got to get a certain something in a certain place. So that's what I'm doing, calculating something that goes 3 past the decimal. And here you see this line is open, and I've positioned it so that it's on the measuring tool positioned at exactly 356.47. So now we're going to go to 356.48 in an effort to find out where 357.5 357.475 degrees. We're trying to find out where that is. So we just want it to be barely over the line on 356.48, and then we can stop the line tool and turn it into a regular line, which is a little more stable, and then we'll just leave it there and measure it from this point because we can get closer to it so as to be very exact. But this line is about 13,000 feet long, so, you know, inaccuracies do creep in, and okie doke. Now, actually, it might be easier to see this. Well, it's easier to see it if the background is all one color, but anyway, we can get rid of that little round thing. Suppose we can position it well enough so that one is ready to be labeled as, what was it, 356 point something, 475, 356.475, and this is the old circle positioning, and we're going to get rid of this. Well, just a minute. That was centered at 356.45, and now we're going to 356.475. Now I've already erased the circle tool things that plot as exactly as we're going to get where the circle goes. So I'll be getting rid of these radial lines now one by one. And we'll start in on the next step for achieving a great big circle as a curve segment of this long tunnel we have here. This is Prescott, Arizona, and this line, this is the more modern bypass. There used to be quite a circuitous switchback type line here. You can see it continues. It was closed around 1960. It went, well, ultimately from Phoenix to Prescott. It was called the Santa Fe, Prescott and Phoenix Railroad, and you see the modern version of that and some of my machinations to get a reasonable speed for passenger service through there. This line is sometimes referred to as the P-Vine, P-E-A-V-I-N-E. Here's the first tunnel. We have three options for this runaround, or bypassing this extreme engineering here from the 19th century, I suppose. And this is the best one for a number of reasons. I think it'd be cheaper to build too, because this area is rough in here, but this is smooth. So, and this one, the tunnel is on a tangent, but here you see the tunnel has a curve in it, and there's just no, the tunnel itself is 1,500 feet longer than this one. It's 10.2 instead of 9.9 miles, so I think that's the better one. I just haven't erased the other ones yet. Now here comes our new tunnel, and this is the first tunnel segment of that. The P-Vine gets a little bit curvy up here, but not as curvy as it gets in the part where I'm suggesting a tunnel. This is the place where the tunnel line crosses a wash or a river. I don't know what that one is called, and then opens up and then goes back into the tunnel here and goes all the way to Prescott. So we'll be showing you that. All right, here we are back at our new center line, and we're going to get rid of the old tunnel alignment, which was 5/100ths of a degree difference. So I'm going to delete that and delete the 9790 indicator, because this new one is 97.95. Hence the center line, it's 3 past the decimal. I wanted to do that to get it absolutely centered between these two houses. See, and now it's 122 from each, more or less. And I think the line will have to, this is quite a point of low cover here, where the elevation is only 5,543 feet. So it might be necessary to make this a vertical curve at a low point here, although the general inclination of the line is from whatever this is, 5036. So it rises up quite a bit in this 7 or so miles before it gets to the outskirts, suburban type housing of Prescott, Arizona. So I guess now we'll draw the first radial line. I always draw them on the left. This curve is going to be 12,500 feet. So this is how you establish once you've established the center line, this is how you establish the radius of the circle. So we're at there, we're almost there. 12.6, 12.501, that's quite close. And then let's see about, oh dear, this is no good. Yeah, it's got to be quite a bit further down there. What is the alignment of this? 255, so it's going to be 90 off that. 345. Here's another low spot. You see there are two low spots in this drawing, and there's a station in the middle of the road right up here, so we want it to be high enough so that, well, it wants to be low enough so there can be a mezzanine to reach the center platform, but other than that, mostly the thing is to have it high enough so it's easy to get to. So somewhere around there, because we have to adjust the length now. It's down to 12,433, so this will have to go back and forth quite a few times here. In this case, you want to be sure that the center line, the line you're adjusting to, is in the middle of the screen, because that will affect, well, no, it's too far to the right. You can see how it affects it. That will affect the final outcome. And of course, the closer you get, the less lateral difference you'll be able to show on the screen, so it's going to be more or less centered. Now I'll make it slightly longer than 12,500. Oops, slightly shorter. Slightly longer than 12,500, and we're only slightly off on the heading now. So this will establish the radius of the circle. And next I'm going to have to show you how to fudge a reasonable looking circle, because the circle tool in Google Earth has nodes, 72 nodes spaced 5 degrees apart. So the trick is to superimpose them so they're only spaced 1 1/4 degrees apart, so that it looks like something, or something close to a circle rather than a bunch of straight uncircular lines. So we're going to accept this as our first radial line here, and the heading of that stays the same, 345. Something on the mouse trackpad here. Alright, so now what we do is find the compass of the circle by subtracting the line on the left from the one in the middle, which is already showing in the calculator, and then double it, and that shows the compass of the circle. Now to divide that by 1 1/4, and so we want to have a little spiral at the end of our fudged circle, so we're going to take 19 times 1 1/4 equals that, and subtract the compass of the actual simple curve of a circle, which is 11,475 times 2, 2295, and you get 0.8. Oh, good, nice even numbers. So we don't have to find any more. See, it's going to hang off 4/10 of a degree on each side. It's going to hang over 4/10 of a degree on each side, which makes things simple because these are all nice round numbers. So 345 is 344.6, I think, but let's 345 minus whatever that was, 0.4 equals 344.6. So that's our next radial line, and we're going to have 4 of them, so we can place circles with their nodes spaced 1 1/4 degrees apart, which gives you a pretty reasonable looking circle, even with this big radius of 12,500 feet. But of course that's not big by high-speed rail standards, but this is the strictly passenger part of this I wouldn't expect freight trains to run on this through this tunnel, so I've made it a narrow single track tunnel. The great big tunnel down there that's 10 miles long would probably be a 2-track single tube tunnel. You've got a lot of rocks and stuff. Oh, I have to change this because it doesn't show the elevation accurately. You have to get rid of that terrain thing now. That's a new feature. Blasted! A new feature of Google Earth, so we can tell exactly how low we're getting. Okay, now one thing that's important about drawing these radial lines is you have to start off, they all have to be drawn in the same direction. So that's why I'm dragging it down towards the center, that's what I did with the first line. And the trouble with this, these calculations is if you draw them in different directions, well, they're slightly different anyway, but if you draw them in different directions, things is not going to line up. It produces a different effect if you reverse by 180 degrees the heading of these lines. So they all have to be drawn in the same direction. 344.6, boy, that's a lot of spiral, and it's not really with the intention of getting a spiral. What was it, 0.6, right? Yeah. Okie doke. Let's make it very accurate. And even though this is quite off as far as the exact theoretical point of curve. That's what I'm calling that. That's where the simple curve would start. But it's better to have your fudge divisible by 1 1/4 degrees outside of that line, unless they're very close to it on the inside, or else you get an abrupt start to the curve, which is undesirable. Okay, so what are we talking about here? 344.6, and then we just add a buck and a quarter to that, and you have the next one, and you go on and on until you get 4 of them. So that's what it takes to draw the framework for a circle in Google Earth. A big circle, I might add. So now I'll turn off the recorder, and now that you've seen one of those drawn, I'll draw the other 3, and then we'll come back and draw the circles. Alright, so here we are with our 4 more radial lines drawn, spaced 1 1/4 degrees apart. So there'll be 4 for every, see, that makes, if you start at 0, that makes that 3.75 degrees. So the next node on the first one you put comes at 5 degrees. It's dividing 5 by 4. So here goes the first circle. And you'll see this center now is getting a little trashed because we've got these lines that are not quite perfectly lined up, but you want to get down good and low so that it's visible. 10 or below. If you've got 8 gigs of RAM, you should be able to go just below 10 feet, the eye altitude, so-called. See, the elevation is not showing because I have that terrain thing turned off. But the eye altitude is that we're supposed to be looking as if it was from 9 feet off the ground. So now, instead of the line tool, we're going to use the circle tool, and we're going to measure the perimeter, the circumference, which is made up of 72 chords of 5 degrees and unknown length in centimeters. So it should be quite accurate. However, I know about this particular circle since I drew the other version. It's going to hang over on one side, and about every 10 big circles you get, 1 in 10 will be like that. And there is no explanation. There are worse foibles in Google Earth than that too, sometimes, but that's one that occurs fairly often with drawing these circles. So we're going to get right up to the tangent line and try and position it accurately. It'll go down to about 25 feet off the ground. See there, 23 feet off the ground. That's what it goes down to around here. And we want to have it more or less centered. This one has to be pretty carefully centered because the length you stretch the circumference to, which is shown up here, it's some 2,397,926 centimeters, and when we get it there, it's going to be about, it's best to record, if you can remember, yeah, this is not going to work too nicely. Just try and get it even with that tangent line. There, that's about as good as it's going to get. Better too short than over, but it's going to be over on the other side. I'm not going to mess with that. I expect, because the last one was, and it was only slightly different position than this. So now what we have is 2,000,0397933, and we're going to record that. My searches here and various things. 2,000,933. Whoops, 397. 397,933, and then when we save it, it's going to be something else. That's pretty good and close. You know, you can't always get it so it's exactly right, but we're down fairly low, and that's quite close. And like I say, better short than over. So what is the measure of it now? The circumference is 2,397,928. So what was it? 9. So about 5 off. I was right, because I've done this one before. This 12. But it varies according to place. It changes according to the place. So now we want the other ones to be exactly the same size, and that's the way you get a very accurate circle. Good enough for representing railroad tracks conceptually anyway. I mean, to draw a spiral actually is quite a task, and it's not worth it because it looks the same as it does as a simple curve, only the simple curve actually looks better. But here you have the effect of a spiral of maybe 100, 150 feet anyway, because the nodes spaced 1.1 and a quarter degrees apart gives that effect. They hang over on either side. You want to hang over equal distances on either side. Now, what was the figure? Oh dear. What was the figure that we recorded here? 397,933. So that should get us pretty much the same figure of 397,928. I usually skip to the one that's 2.5 degrees away from the first circle drawn, and you can tell that they will intersect at 1.25 degrees on either side, and this is about the right length. 397. Well, it's not long enough. This doesn't have to be so exactly in the middle as to up and down. 93397. What was it? 397,933. Only laterally it should be in the middle. Up and down, it doesn't matter if it's in the middle this time. But you're 23 feet off, so it's a lot more sensitive to being off. 297,937. 133, exactly right. So that's the first or second circle, and they'll look probably pretty accurate. They should intersect at these places. Sometimes they don't. You know, you can never figure out what's wrong with it if they don't. But unless you have one big one and one small one alternating, see, we don't see how it lines up with the middle line yet. And I told you this is going to be over, and it's not yet very much, but it's going to be. This one is going to be over, and so we'll have to fudge the line itself. Everything has to be slightly fudged. So now I'll draw two more of them and discuss more about this particular project, and you can see the outcome of this magnificent 12,500 foot radius circle. Now, before we go on here, I've created this little interlude with a dusty picture of my keyboard. Boy, I tried with my USB vacuum cleaner to clean that up, but the morning light here shows the dust, so you have to look at my keyboard. One essential thing for this is you need 6 navigation keys. Without, you would need 3 hands. So while Elon Musk might be able to provide a satisfactory solution for you there, I suggest getting a computer with 6 navigation keys. This is a 2012 ThinkPad. I believe Lenovo still makes ThinkPads with 6 navigation keys for $3,000 or so if you want to have Xi Jinping following you through the dark web. But Dell makes one with 6 navigation keys, and also a touchpad with buttons instead of a trackpad. You see here, this is my Lenovo trackpad. I believe this was one of the first trackpads, and it has quite a few adjustments on it that you can try and make it so it works the way you want it. It's still not quite up to having mouse buttons though. Anyway, you gotta have 6 navigation keys because you won't have enough hands to do this without. All right, now, so here we are with our great big brand new circle. Let me show you the. It's quite a long circumference, even with tangent chords. The 72 tangent chords. It's almost 15 miles, the circumference of this circle, to give you an idea. And our first order of business will be to reposition the tunnel line already drawn. It's a tunnel throughout this the whole part we're going to show you here. It divides here for the station, somewhere around there, and it's a little off now in relation to this new circle. You see it's a little lower in the picture, so we have to change that, and we'll have to narrow it down and make it more visible by making it white, and then we can just start rearranging these things. You want to do it inaccurately first and then come back and go down low on it to get it exactly right, or as close as possible. There's some practice involved in knowing where these things go at these nodes of the 4 different circles we're involved with here. And then there's the matter of fudging the overhang here. As far as addressing that in a better way, well, see, that's somewhat overhanging, but the start of the curve proper is way off, maybe a foot off. I don't know how far off that is from the tangent. Let's close it and measure it. This is an extreme case. Of course, it's aggravated by the extreme size of the circle. One way you might address that is from back at the beginning of the movie. You remember I was positioning the thing to be at exactly halfway between 0.47, what was it? Between 0.47 and 4.48, so it's 0.475, and it looks to me like you might want to have it somewhere towards, see, it's almost 3 feet off. That's no good, but if you redrew it, you might have it positioned right at 0.48 and skip the 1,000th of a degree place there, 3 past the decimal. Alright, so we'll start trying to arrange these and fudge them at the same time. Let's see. You'd have to do a lot of experimenting to place it right. I've tried it that way, and usually, but not in this instance, I would say it's better to just fudge it. Alright, now we're going to have to go in at least, where are we? Well, a bit here. Doesn't need to be 2 feet. Of course, this is all guessing as to where on your circle nodes these things would fall. You'll want to have this one a little inside the desired node, and then I think the next one will just set it exactly on the node we've created to as a guide to drawing circles. You can get a better look at it sometimes, not in this particular configuration of computer, but sometimes it's easier to see exactly where it goes. But if you have them, if you have the lines more or less lined up, well, you just try and get it so there's no room between the highest point on the node of the guide circle. So we'll do a few of these, and then maybe we'll look into the elevation of this tunnel line. See, that one was easy to do. And it's pretty accurate because you run down to 23 feet above the ground as viewed in Google Earth, and so it's quite close. There you can see the stepwise progression, just barely. On some computers it's more prominent than that. But in those cases you can see exactly where to put this thing, and it's right about there, but it's hard to see on this one. I think it's because of the it has a dull finish, so you know some of them have a glassy finish that reflects the light, and this one's supposed to have the dull finish, but it kind of adds some distortion of its own. So you see here we have our tunnel line approaching from the west, and we still have our one tunnel. It's almost the same position here, the one preliminary tunnel before it crosses over this river or wash, and then tunnel all the way to, and there's where I've stopped. I'd better oh no, I've moved quite a bit. Oh no, this is the one we didn't do yet, I think. So you gotta have that marked, and you see it took quite a while to place all these nodes, but if you want a node every 1 1.25 there's a missing line there, every 1.25 degrees, so you get a smooth looking circle, that's what you gotta do. Here we have a bigger circle with a 2,000 foot radius coming right into the station, and I won't be drawing the platform in this instance, but it might be nice if the other end is quite close based on this tangent here. It might be nice to have it a little tapered and rounded at the end. That'd be sort of a design characteristic that might be desirable. So I'll finish pasting this thing to the circle by manipulating the nodes, and I'll get back to you with some elevation investigation of this thing. I know it'll work, but I think we might have to add a vertical curve here somewhere. Alright, so now we've finished our very broad tunnel curve. And although you don't generally want any curves in tunnels, the broader the better, though. As for speed, well, it would be a narrow tunnel, you know, with probably enough room for an escape route underneath, so it would there would not be such terrible back pressure on the air, but you know, I think 100 miles an hour tops through here. I don't think you would want to have narrower cars, but you'd certainly want to have shorter cars on this line, because some of the curves are have 500 foot radius, and they would be hard to change, you know, without some other big massive infrastructure project, because they're cut into the sides of hills, and the stuff is not all that stable. So if you go trying to expand a radius on a curve like that, you're asking for trouble. washouts and so on. I understand that this line was very well done and was not subject to that kind of thing. And it was completed about 1900, so they had some clear idea of what they were doing by then. Anyway, you see the orange line, that's our new tunnel line, and it's tunnel all the way through Prescott. I wanted to show something, to fix something, because I noticed it, so I'll have to reduce it to the narrow width, so you can tell what you're doing here. And then see, because I put this in the, when I fudged the overhang here, I put this one of them in the wrong place. There's the start of the curve, but we have to compare it to this side over here. I just noticed that's going through the last 10-minute segment. See, you have that's point of tangent there, and then I don't know how long this is. It's quite long now. Well, I can't open anything to. Well, I suppose. Yes, I suppose I could. Let's see how long it is, because the second node is quite close to the tangent. In fact, oh no, here's out beyond the radial line that defines the radius. That's the simple curve would start there. So we're how many feet beyond that? 87.5 feet exactly. And then to the first node is so between nodes we're talking here for purposes of creating the illusion of a circle. It's 275 feet, so that's well, this is a very long radius, but so that there is quite close to the tangent, and as a result of, I wonder if engineers actually engineer curves this way. I doubt it, but usually they have an offset on the side or both sides that they want to spiral, and say this is 2,500 feet, you'd have an offset of 12.5 feet, so the circle would be down here somewhere, and then you would start the spiral opposite the curve and run it out to way beyond the curve on the tangent, except we don't have much room to do that here because our next curve starts right away. That's a curve I created. It's 1,250 feet, so 1/10 the size of this 12,500, and then these are curves compliant with the design of the road, which curve is 975 feet, it seems to me, and you have quite a short tangent between the reverse curves, no more than 200 feet, just about 200 feet. Anyway, what I noticed here was that this first node before the point of tangent is quite close, and I didn't draw it like that when I was fudging it over here, so I got to change that. And then we'll get into some of the some of the elevation of this tunnel, whereas mostly it's not in any danger of being too close to, oh, what happened here? Oh, well, that's part of the fudge there, see? Very nice. Fudge. Alright, well, first of all, this should line up with a tangent, which it does now, though, and we're right in the middle of the screen, so that one's okay. Then it seems to me, though, that I put this is the second one. It's farther from the tangent than the one on the other side, so I wanted to run it up. Should be at least as close to the tangent as it is on the other side, because the other side isn't snafu'd with an overrun of the desired spot. So here we are, and we can move this one back a little bit. You'll never see any of this if you're just looking at it, but we want to get it right. Our fudge must be as carefully done as anything else, and when so much of it is fudging, why, that counts for a lot. All right, so next we'll try taking a look at the elevations, and we can get rid of some of this lines here, so now you can see what it looks like, although I've left some lines over here to continue from the station here. See, these are curves quite broad, and you'd have maybe a round-ended platform that tapers a little bit, and then it has to extend 2 tracks all along here, underground in Prescott and above ground to reach the Prescott station proper. And then there's a few more. There's the old station. There's a few more. There's this Yavapai College campus and another place by waste treatment plant is looks like a desirable station. None of this has been drawn. This is just drawn. This is just eyeballed. And then you come to some of the most beautiful scenery. It really is stunning scenery. Let me turn on the pictures here so you can see what this is. It was a very popular route for passengers, and I imagine some of this scenery is why. If you see, oh boy, there's a tree that's drowning. Maybe over here. This kind of rock formation here is quite stunning, and amidst the natural lake, I believe that's a natural lake. So, we'll be looking at elevations and stuff. Down here you have the line splits up, and this was already built. It's really a beautiful scenery. I was thinking that this is a very populous spot here, Prescott Valley. You see there's quite a bit of built up in there, so this might be a place to have a storage and maintenance facility if that could be swung, and then Prescott Valley would be able to get to the airport easily, which has to be underground because of the FRA, or is it the FAA? The FAA is very particular about what runs near their properties. But this is the new main line as I've re-imaged it. sort of basted it with points of intersection curves, no curves drawn. It used to run over here somewhere. All right, so much for that. All right, so now we're looking at our new tunnel line from the south. That is, down here is Phoenix, and the remainder of the Peavine line goes up to here. You have here, these are a couple of 500-foot radius curves. And then the tunnel, which I've already explained, the one preliminary tunnel before it goes into the main one about here, as I have it marked. But that'll have to be checked again to get a reasonable facsimile of where the tunnel starts and ends. So let's look at the elevation profile. I've exaggerated it quite a bit, and we've got the end of the tunnel about lined up. That's about the right size. And you can see here is the summit of this. It looks like it has a road running through it. Let's check where the summit on the old line was, because I happen to know. Was somewhere around here. I'm looking down at this elevation indication here. Now where is, here's the old line, comes up through here, and there is a bit of a horseshoe curve, and it's 6,000 feet. Here's 650, and about here is the summit, 6107, 6115. So there was a summit station here, and you can see a picture from about 1900. It looked like this. You see the train is up on a fill there, and the summit station is apparently on a curb, and here's a diverging track. But Santa Fe main line didn't come through here, but this was the line used to get to Phoenix, and then I suppose if you wanted to go on to California, you could take the SP or something. That then was about the only way to get from Phoenix. If you go over the Santa Fe from Phoenix, it's quite a circuitous route over to Barstow. Boy, that's hundreds and hundreds of miles out of the way. Not that the SP is much better. That's what I've been trying to find a way to put the Santa Fe straight through. Anyway, let's look at the elevation here. So we're going to look at the elevation profile, which I have quite exaggerated because it's easier to draw, and you can tell what you're drawing. This doesn't have to be lined up, but it's nice to have it that way. It's about right. So we'll want to take a picture of this and then start drawing to first we'll find the position of that tunnel portal, and then we'll want to know over here, although I've already checked, between these two houses now there is the low spot, but the two houses are up here, so the track top of rail is going to be more than 200 feet below that. So I'd say, aside from any other need, there's no need to have a vertical curve right there, because we have this other low spot, and then it rises under the road. The surface level rises, and here's our station. We want to be pretty close to the surface there, so that will take some detailed work that we may not get into here, but I thought I'd try and demonstrate how this is done. We'll go put our the trouble with this thing is that if the indicator is off the picture, it will move to the picture and put the the arrow of your grade thing in the middle, and that can be quite annoying if you're trying to stop it from moving. So there we are, and we'll make our picture of it about here. It seems to me that lines up pretty good, maybe a little larger. Well, you can't get it exact, but whoops, I should have not shortened it. I should have, there, how about that? A little larger. Oh, what's wrong with having it a little larger? Well, you want to be able to see it all here. Here's a better way to do it. There. That's nice. Okie doke. So we'll run this back to here. It's still too big. It doesn't exactly correspond. In any case, we'll take a screenshot of it and close the Windows Paint, and then try and see if we've got something here that can be used. Oh boy. How did that get like that? Oh, it's gotta be cropped. And we're gonna lose the part of that elevations on the side, but I think we'll be able to tell what they are anyway. So there's that. And we'll save that the way it is. I think it was this one. We'll just change the name to what that one is. And now we're ready to try and we want it to be as close under this low spot as possible. And to set it, you can double it. You can only double and quadruple things here. There's not much else you can do, but to get an accurate start on this, you want to start at the low end, and that's 5036, and try and draw a narrow black line from the beginning, and then we're going to see how that can be arranged. get up under that road close so that so this is a negligible grade. How about here we'll make our change, but there's no way to tell the exact location of that, so you want to have a perfect, see what is the location of the two lines. They're quite far apart, I think. Oh no, they're only 100 feet apart. Good, so all we have to do is find out what that elevation is. And it's what? 5,400. No, 5,500 is about the level of the low spot there. I don't know what I'm doing here because this is a different way than I was doing it before. So let's see that low spot and try and guess if top of rail is here. Would you say that's 5,480 probably? Better make it 5,475. Because that's just below the surface. So we're going to put our vertical curve at this low spot, and so far as we are able to do it. And then continuing on from exactly the low spot, let's enlarge it to be sure. We'll try and increase the grade since this is a negligible grade. It's about 1.4%, about not very much. 1.04, I mean. Now wait a minute. Well, it might be 1.4. In any case, we want to rise up here, and this is in so that's top rail about 20 feet below, and you can't have that, so we should have just continued it up to here. 2.8 now. Unless we go back, because then you can tell exactly what your how high is that, I wonder. But it looks like it wants to be pretty much level all the way past that low spot. See, here is where the houses are way up here, so that low spot is of no concern at all. Alright, well maybe we'll run this back and run our line right by that low spot. Let's see how that works. thing is going to be at, but I don't want it to be 100 feet down there. That's an awful situation for trying to get to a train station. Let's make it, what would that be? There is 50, so how about 25? 20 might not be okay. It'd probably have to be 10 above the 100-foot mark, whatever that is. Because, oh, on the other hand, I mean, low cover is not a problem if you're not underwater or something, so why not make it? Well, it'll be sticking up above the ground, that's why, and that is a wash that is active with water, so it'll need to have, it needs to stay at the elevation it's at. So, while I'm not going to put this at 100 above the 100, at 10 above, at 20 above, I'll assume that's about 10 above, and then we can increase our grade up to the station from there, but we don't, of course, know where that is. Let's have a look in the, so here we are, this is 5584, so we're about 5510 here. At this big hump that the road apparently goes over such a hump. Now we're on the other side, so at about the height of that hump, there it is on this curve, and here's where it comes and splits. So you don't want any vertical curve where the switch is. And I have the thing as being about, so there's room to get from the vertical curve that is centered right where that red arrow is. And that point of vertical intersection would be 5510. 5,510 feet. And then we're going to keep going up as the ground comes down, and we'll see where the center of the station is. It's at 7.74 miles. But that's something we can't, at 5550, just about 5550 on the surface. So for 5525, that won't be too bad. If we can get up there, let's see where that is again. On the picture. Well, it's a little more than halfway through that. It's an inexact science here. Trying to plan these things in Google Earth, but now what was it, a little more than halfway through? Yes, I believe so. 55, 54, 51, that's what it was. 5550 is the surface at the center of the station. So we're going to try and locate that on this illustration here. where is 5550? About there. So by that point we want to be 5520 anyway. If not better, I'd rather it be 25 because these are not going to be any freight trains. So let's see if it's 5520 and we've sort of moderated our incline. So, well, let's see, it would have to change right in the station, which you have vertical curves in passenger stations. Penn Station has two of them along its platforms. So there's, or is it only one? It might be past the platforms that the other two are. Yeah, I think so. There's only one at the center. So let's see. What did we say this was going to be? I think we're going to make it 25. Oh, well, see, we should have just continued it up. There's 50, right? So you want this to be 25. Somewhere around there. It's almost as if it didn't change. So I'd say, anyway, well, that's about the alignment of it. So there is not much of a change at this vertical curve here. I was using that line so you'd be able to tell where it is. But anyway, it gives us an idea of exactly what this what this looks like over here. So it's not outside for very long, and we'll have to try and imitate that to get the proper location to start the tunnel back over here. So here we go through the first mountain and coming out. We want to make it look something like the other, and I believe it's just about exactly the same as I had it before. I think we'll put it a little to the right of there. This new alignment seems to have it affected differently. So, and it's a little higher up than it is in the picture, so we're going to mark our tunnel portal here, and then we'll make a copy of this. Let's get rid of this one first. We'll make a copy of this tunnel line, which is called something or other. Prescott Tunnel West Leg, and save it in among all this stuff. There's already one there, and then we'll go to that oh dear. Well, where is that? Oh, I see. It's in here somewhere. What was it called? Prescott P-Vine, Prescott Tunnel West Leg. That's the one we just saved. So now we're going to add a second. We'll have to drag it out of the container here. Prescott Tunnel West Leg, and then we'll discard the container. Prescott West Leg, Prescott Tunnel West Leg Tunnel. So as not to cause confusion. Oh dear, I didn't mean to do that. And where is the end of it? Here we go. And of course, the tunnel runs right to the end. Let's be sure this is accurate now, although it doesn't hurt to have it a little bit off as far as being lined up right over the, I don't think we're going to go any deeper than that. Oops, you just wrecked it. We have to start over again. Ah, phooey. Here's Prescott Tunnel, West Leg Tunnel. Right? See, it's the other way. I was that. What I just did, it would have dropped a node. So we'll just try and position this more or less accurately. Luckily, the tunnel goes to the end of the existing part of this line, so. There, that's pretty good. And we'll make it look like a tunnel. Beautiful. So there's hardly any vertical curve. Once you get past here, there would be a vertical curve, and then here we can get rid of this marker. That's about where the tunnel starts. As far as the two houses go, this low point is over here, but the land is quite a bit higher here. It'll be 200 feet below them and 122 feet away from them. And most, or many states, 200 feet below the surface means the thing doesn't even exist. So, of course, you don't want to make fun of anybody's helplessness as far as there being close to a train tunnel, but with a purely passenger tunnel, you'll have all smooth wheels, no square wheels, bad brakes, like Norfolk Southern or someone, speaking of dangerous practices, and heavy axle loads. It does contribute to throwing axles, as they did there anyway. I'm not going to talk about that. So here we are at the station, and there's just not much movement at that vertical curve. There's not much of a difference in angle, but that's the part I intended on finishing, and so there we are. Actually, no, it isn't. And I'll tell you how we got the grade, and it isn't even as it's quite a bit lower here. I put it down 50 feet below that wash you see in the Google Earth imagery, and I'll explain that in a second. And I'll try and tell you how you get the figure percent grade. Right now, it's pretty simple. You subtract the lower number on the left, which is actually 50-40, because the grade profile differs from the grades you get from ticking that terrain box in the left panel. And the grades that you get by hovering over the imagery are more accurate than the ones in the grade profile. Sometimes they corroborate, sometimes they don't, and that can be checked with the U.S. Geological Survey Google Earth topo map. If you Google that, you'll get a download for dropping into Google Earth. It's not really well, it's a download. And you can use that to check the satellite-generated elevations with the Google Earth topo map, U.S. Geological Survey. So we subtract the lower number, which is now 5040, and then you divide that by the length of the grade, and we'll have to go into Google Earth to get that. So it's a little over 1%, and the way you do that is save a line extra. Save this, it runs all the way back to the beginning of the grade, which is about 7 miles back here. Save that separate from the one that's in the Google Earth tree, and then calculate the distance in feet. So you divide the rise by in feet by the distance, and you get percent grade that way. Whoops. Didn't intend to do that, but that'll do for our purposes. What is the distance here in feet? So this is a low spot. I've decided to put it 50 feet below for the time being. Maybe you could get away with 25. I don't know, because this is a permeable piece of property here, and here is a water storage arrangement. I don't know exactly how these work, but I imagine there's quite a change if there's a big rain, and we don't want to block the permeability of it. That is, you know, stuff that's paved is called impermeable. So this is permeable, and it wants to remain as it is, I would imagine, and avoid any disturbance from tunnels underneath. So that has to be mitigated insofar as possible. So maybe the tunnel needs to be 50 feet below. It's still possible to get an acceptable grade into the station, but it makes it more difficult. So here we have the distance, 6.85 miles, but we want to measure it in feet, so it's 36,147. And we divide the difference in elevation of the two spots by this figure. And what you get is well, you have to move the decimal point over 1.134%. I don't change the decimal when I enter the divisor, because this figure you can use to calculate other positions by multiplying the distance by this figure, by the quotient here. So that's how that's done, in case anyone's interested. Now, let's see. I can cancel this and the... Whoops! Why didn't that work? that line should be back up here, shouldn't it? So that's the grade up to the low spot, the second low spot, whereas the first one is back here by these two houses. You see in the diagram, these will be about 300 feet. The top of a rail will be about 300 feet under those two, so I don't consider that an issue. Actually, I did try, first off, I tried running a gigantic tunnel from, Kirkland here, about a 20-mile tunnel over to Prescott, and unfortunately it has to come up pretty high below the ground, and then you would get a bunch of people who didn't want that. So that's what you get. Now the distance from the low spot to where, I'm not quite sure, but you can take your to the very middle of the station. I just did that arbitrarily because you wouldn't want such a pronounced vertical curve there. But let's see, that's 4,046 feet, and we want the elevation here to be, let's see, 55, 58, about 45, oh no, it's 55, 12 and a half. About 45 below the surface there to have room for a mezzanine. That is, assuming you have, no vista domes or high-level cars. I think you could have plenty of visibility available in these cars, but they want to be special because of the sharp turns. There's a few left that you have to keep, as far as I'm concerned. So let's see, what's the next thing? 55, 12.5 minus whatever the elevation is at the low spot. Oh, that is the low spot. Oh, I see, we're subtracting this from 55, 12 and a half back to 54.50. Is 62 and a half, and then what did we say was the distance there? Divided by 4046, 4,046. So divided by 40,046, and you get 1.5%. So it's not a terribly steep grade. But the problem is, if you move that point of vertical intersection back from the station, you're going to get a steeper grade, and you don't want that. So I think it might be best to leave this vertical intersection in the center of the station, and perhaps have it a little bit higher with a very long radius of vertical curve. If it extends, say, 2,000 feet back, that's about halfway to the low spot. So you could raise the point of vertical intersection some feet in order to compensate for the long vertical curve, whether it's a simple curve or parabolic, I don't know. It's not especially any high speed, so it might as well be a simple curve. And get a gradual rise to the station and an imperceptible, almost change of grade in the station. It might best be at that point. The IND subway in New York comes to mind. where at 34th Street and 6th Avenue, the line dives under the 31st Street tunnel from Penn Station, which is a two-track tunnel, two tubes, or I don't know, it might be an open caisson arrangement there. Dives under it. It's customary to build new tunnels under old ones rather than from above, because it tends to cause disturbances if you build above. So that's what they did. And you can see the dip in the station. The station's about 650 feet long, and the entire dip and vertical curve is accomplished almost entirely within the station, I would say. And if you didn't know it beforehand, you would never notice it. So a more broadened out vertical curve in the opposite direction here probably wouldn't be of concern to anybody. Now I wanted to examine back here, or point out back here, this is the steep part of this line coming from Skull Valley back here. You see it's pretty gentle. I didn't actually measure this, but it's pretty gentle going up until you get to, oh, this is the whole thing. Well, it gets quite steep right around here. There's a big trestle. It comes around this very sharp curve. This is a 500-foot radius curve, and then there's a trestle here, an old wooden trestle. You can see the remains down there. I don't know why they line up that way, though. I can't figure that out. And that is the low spot, and then the grade increases to about 2.875 all the way up to the tunnel. So that's quite steep, and the fact that you have to slow down so much to get around here is a problem for ascending trains, even if they're electric propulsion, or preferably conventional rail with linear induction. You have that in the Morrison, Knudsen, what is the brand name of that thing? They make linear induction things with third rail. It might be good if you could dispense with the third rail, though. I mean, maglev doesn't have third rail. I don't see why conventional rail would have to have a third rail. In any case, I drew this circle here and have forgotten the radius. I think it's about 2,000 feet. I don't know. I wouldn't be able to ascertain that so easily. Let's see what it is. But it could be considered problematic, that's for sure. Maybe I made it 3,000 feet because it wants to be far enough back. That's the trouble. It wants to be far enough back from it so there's some cover there. And there's not a lot of cover. It would have to go first in a cut and then in a short tunnel and then another cut on the other side. So it's a problematic place to develop with a short tunnel. That's 3,000 foot radius, and I'll show you what it looks like here. See, this goes back to not to Skull Valley for sure. Back, how long is this whole thing? 1.5 miles, and extends up there. So what you have here is, if you can build a tunnel and a cut here, then into the tunnel, then in a cut, say 4,600, 4,650. So only a maximum of 25 feet below the surface. Then you exit the cut here and run over the trestle. Why you'd be able to get through that without having to slow down, which is, if anything, a more energy efficient way of doing it. And then you can get up this hill. It doesn't get too curvy until you get right up here. That looks like quite a tight curve in the reverse, and these we know because I've measured them are 500-foot radius, so you'll be going pretty slow when you get up there in any case, but it'd be possible to mitigate that some with a tunnel there. It might be pretty expensive, but then you get a better alignment. I don't mean to sound negative about using the original line. I've explored it pretty thoroughly between Phoenix and Ash Fork, where it meets the main line of the Santa Fe, and was, for a few years anyway, the only way to get from Phoenix to California. And the original line in many places, well, it's more the original line than not, for sure. There's just a few shortcuts that make it take a lot less time to traverse. Especially at Ash Fork, there's a couple of tunnels you could add and restore the old line through Ash Fork. And use that for a fast passenger service rather than the high and circuitous, but a lot faster route they developed in the 60s to get around, well, not to get around Ash Fork, but that's the effect it had. It closed down that town, and the other one, Williams, where the trains go to tour the Grand Canyon. I guess it's called the Grand Canyon Express or something. So it's a desirable line, and there are a lot of there's a lot of population along it that I think would enjoy using it. And the original adds, if anything, a lot of scenery and drama to the ride. It makes it much more dramatic if you know you're riding over something that was built, more than 100 years ago. And the first 30 miles going north out of Phoenix is a gold mine. If you could get some cooperation from the freight railroad there, maybe eminent domain should be reversed and used on them, I think. So, thanks for watching, and I hope you didn't, you do best to skip some of that groping for the grade, but that's what it's like. You never know what it's going to be until you try and do it. So, it's sort of an unusual video to try and do, and I hope some people like it. Maybe somebody will like it. Thanks again.